good chance for me. Thank you very much.
Thank you very much. Jihak?
Good afternoon, everyone. My name is Jae Lee, working at Kiosk. I'm the physical oceanographer. Okay, thank you.
Thank you. Next one is Kun, K-U-M. Sorry, I don't know how to pronounce. Sorry. Oh, cannot talk. So next one is Lin Lin.
Lily's doing
in
taxi.
the car.
Okay. Next one is Mizue Ijima. No? Okay. Someone seems to be difficult to show up. So next one is Tanaka-san.
Yes. Hello. It's so nice to meet you. My name is Kiyoshi Tanaka from Tokyo University, Japan. I'm a physical oceanographer. I'm interested in the dynamical interaction between coastal circulation and the Kuroshio current. Thank you.
Thank you very much. Next one is Shi Jiang-Hu.
Good afternoon, everyone. I'm Shi Jiang-Hu.
May tao dito, paka-ano na lang, please. May tao.
Hello, can you hear me?
Yes, clear, yes.
Yeah. So I work in Institute of Oceanology for Chinese Academy of Sciences. I work on ocean circulation and climate in the tropical Western Pacific Ocean. I do in situ observations. So I'm very glad to see you online. And thank you for providing such a good opportunity.
Thank you very much. Next one is Sraya. Sraya, can you talk again? Oh, seems to be difficult. So I skip.
Slava.
Oh, Sraya.
Hello, my name is Vyacheslav Lobanov. I am glad to see you. I am a director of V.I. Ilyich Pacific Oceanological Institute located in Vladivostok, Russia. Traditionally, Russia participated quite efficiently in the first CSK since 1965. This time we work more close to Russian seas and Eastern Arctic Ocean, but we are still interested in far seas and far ocean like Kuroshio, because branches of Kuroshio comes to are close to Russian area also, and the warm core rings comes to Kuril Island area and so on. So I very interested, and I'm glad to be here in such a nice company of people interested in Kuroshio. Thank you.
Yeah, thank you very much. Nachapa, your microphone is on. Please turn off your microphone. So next one is Songkyat. Songkyat, not here.
ใส่จานรองให้เขาก็ได้
Okay, I skip. Next one.
Your microphone, Songkyat. Your microphone is off.
Okay, so I will skip.
Okay. Could you hear me, Ken?
Yeah.
Yes. Yeah, I'm Somgyat. I used to work in the Phuket Marine Biological Centers, and now I moved to work with the WESTPAC office at work with the Venchi. Yeah, thank you.
Thank you very much. Next one is Hyun Nam from Seoul National University.
Hello everyone. My name is Songhyun Nam. I'm from Seoul National University, and I'm a physical oceanographer, and my interest in the ocean circulation and the physical processes covering quite broad ranges of spatial and temporal scales. And I'm involved in the Pisces Pacific ICES, and one of the advisory panel in the Pisces AP CRIMS. So I think I'm here to somehow represent or think about the relationship with the PICES program. So very glad to see you all.
Thank you very much. Next one is Zhao Hui Chen. Sorry, I'm not sure if my pronunciation correct.
Can you hear me? I don't know whether you can hear me.
Yeah, I
Can you
hear
hear
you.
me? Yeah. Oh, good. I'm Zhao Hui Chen.
Up-
Yeah, your presentation is very good. I'm Zhao Hui Chen from Ocean University of China. I'm here. Recently, in recent 5 years, I was deeply involved in the observation network building in the Kuroshio and the Kuroshio extension. Hopefully, we can have more correlation in this region. Thank you very much.
Okay, thank you very much. Next one is Hanna. Hanna-san? It's difficult to connect. Hanna?
Connected, but microphone is muted.
Okay.
No, his video is muted. Microphone is on. Her.
Okay, maybe some trouble. So maybe it's fine. Who is Y? Who is Y? And one, I see one Chinese character's name in the list. So who is?
It's Jun Qiao. I think it's Professor Hu's group.
Okay.
Yeah.
So can you talk and show up your video? No. Okay, I think we finished all. So I pass to Xiaopei. So please start, Xiaopei, this session.
Okay, yeah, thank you, King, and thank you everyone to join with the CSK-2 webinars. And I think King will give a brief introduction about this background. So for me, I will mainly talk about the agenda of the next month that I just share the screen to everyone. And here is the agenda for the whole webinars. And today we will have 2 talks and also 1 opening remark. The opening remark will be by King, and the talk will first by Dongliang and then by me. And in August 7, we will have 3 talks and by Andros, Ogi, and Hannah. And in August 14, there are also 3 talks by Hiraki, Masami, and Akira. And in August 21, we have 3 talks by Cesar, Pengbin, and Shijian. And in the last webinar, we will have 3 talks by Kuroshio, Jackie, and Fan Wang. So we will actually have 14 talks, and I believe that will be a very successful webinar. And also for each talk, we wish you can finish it in 20 minutes. So we will have at least 20 minutes for Q&A. And also for each talk, as we have mentioned before, we will talk something about what you want to do and how it's related to the CSK-2 Science Plan. And one important thing that we will wish that your talk will try to link about the UN decade for the marine, for the sustainability of the marine science in the next 10 years. Okay, I think I just stop here. And so King, I think it's your turn to give the opening remark.
Thank you very much. Could you please show the agenda again?
Okay.
Xiaopei,
sure.
Just
the agenda.
Go to the end. Please go to the end. I think,
okay.
Important information to the end.
But we list 3 important information, and I just briefly talk about this.
And all presentation will be requested to finish in 15 to 20 minutes. And the remaining time will be used for the question and answer for the better consideration to the CSK-2 Science Plan. And all the talk will be recorded for sharing with other speakers who will not be able to attend. and also for creating the CSK-2 Science Plan to be submitted to the next IOC-WESTPAC session. And I would like to ask all materials for presentation will be requested to share with co-leads for that purpose. Co-leads are myself and Xiaopei and Cesar. Yeah, thank you very much, Xiaopei.
Okay, thank you, King.
Yep.
So now we will, I think we should start now. So King, please give a brief introduction about the CSK-2 and also our webinar.
So how to share? Xiaopei, I cannot share.
In the bottom, there is a panel. So share your screen. Yeah, in the bottom, in the middle.
Yeah.
Oh, yeah. Yes. Okay.
Coming
we
up?
Can see.
Okay.
Yeah, coming up. Yeah.
So my talk is about the, I just introduced the history of our activities for the development of CSK-2 science plan, and also I want to introduce the UN decade of the ocean science. So this is the a kind of history, how we, developed the CSK-2 review report and science plan. So we started from the January 2017. We had the first workshop in China, and then in the third bullet, we meet again in China as a second workshop. And in March 2018, we finalized the zero order draft of the review report. And August of 2018, we accomplished the first order draft. And then we present the second order draft of review report for CSK-2 to the WESTPAC advisory group meeting in Manila. And we received the recommendation. One of the recommendation is maybe it's better to develop the CSK-2 project for the UN decade in line with societal needs. And third meeting will be was held in Japan and to discuss based on the second order draft of review report and decided to develop the science action plan. And we plan to have the fourth workshop in November 2019 for making science plan, but have to postpone to February 2020. But again, due to the COVID-19, we could not have the workshop. Instead, I submitted the review report for the CSK-2 to the progress of oceanography. So the review is still undergoing. And now we decided to have the webinar series for development of science action plan. So this is the outline of the history of our activities. So this is the contents of the review report of CSK-2, and I skip many. So first we review the achievement since the CSK-1, and then we try to identify the present scientific knowledge gaps, physical, biological, and biogeochemical aspect. And we seek the needs for CSK-2 in section 5 and try to summarize. The total number of pages is around 70. It's a very huge review report. And during the preparation of the CSK-2, we have had the the UN Decade Ocean Science for Sustainable Development project. So this is still under the preparatory stage. This preparatory action has started in December 2017. At that time, the UN Decade of Ocean Science was proclaimed in the UN General Assembly. And then going to the 2018 and 2019, 2019 May, we had the global planning meeting at Copenhagen. And in the last, 1 year before, IOC-WESTPAC together with the PICES and the Japan National Commission for IOC conducted the North Pacific Ocean Marginal Seas Workshop at Tokyo. And after that, zero-order draft of the implementation plan of UN Decade of Ocean Science was issued. And June 2020, right now, member states is reviewing the first version of implementation plan. So this is a timeline of UN Decade of Ocean Science. And this is the kind of the information, collected information, how the implementation plan was developed. So sorry, someone's microphone is on, so please switch off your microphone when you do not talk. And this is a vision and a mission of the UN Decade of Ocean Science for Sustainable Development. So we have a vision, the science we need for the science for the ocean we want. Mission is transformative ocean science solutions for sustainable development, connecting people and our world. So please, all participants, please switch off your microphone when you do not talk. Thank you for your collaboration.
Okay, your microphone is on. Okay.
As a host, you can mute participants. So
okay.
You can mute Augie share.
But I'm sharing my screen, so I cannot do that. Thank you. Okay, so this is a vision and a mission.
Sorry.
And in the implementation plan, we have 7 outcomes. One is clean ocean, one is healthy and resilient ocean, and productive ocean, predictive ocean, and safe ocean, and accessible ocean, and inspiring and engaging ocean. So this is a very top level outcomes as a goal of the UN Decade of Ocean Science. And this is the framework, action framework. So at the top, we have a decade outcomes. And at the second level, we have the Ocean Decade challenges. Third level, we have decade objectives. And finally, we have decade actions. And at the second level, this is the initial challenges identified by IOC Paris. So we have several decade challenges. One is the pollutant, and another one is the ecosystem and their biodiversity, and sustainably feeding of the food issues. And fourth one is ocean economy and ocean climate, the IPCC ocean warming issues. And this is the multi-hazard warning systems and ocean observation and IT system. And this is the information, knowledge sharing, and capacity development. And finally, probably this is, I think, one of the big challenges, behavior change through the ocean science. And as a third level, this is objectives and sub-objectives. In this level, the importance is, very simply speaking, the co-design the value chains of ocean information with stakeholders. So, so this is a very famous, sentences. I copied this slide of the Professor Uematsu. So he copied these sentences. The science is facts, just as houses are made of stones. So is science made of facts, but the pile of stone is not a house, and the collection of facts is not necessarily science. So this kind of things we need to do. And at the fourth level, this is the decade action. So under the decade action, we have 4 categories. One is decade program. This is very big program. And the second one is decade project, and the decade activities, and the decade contribution. So I hope the new CSK-2 will be listed in future in the decade of decade program or decade project. So next step of decade is like this. So in September 2020, IOC will outreach to identify flagship actions. And October 2020, we will have the first open call for actions. And in the meantime, in parallel to the preparation of actions, so IOC will try to get their omnibus resolution by UN General Assembly, including the implementation plan. And then January 2021, decade starts. And in parallel to the starting of decade, we're gonna have the call for board nomination. UN decade board is one of the governance system. And February 2021, we will have the second open call for actions. And if in time, we may consider to submit our CSK-2 plan to this second open call. And then we will have the kickoff events. So, so through the UN decade period, of course the science is very important. However, maybe the development of data information system and also the achievement of the literacy is important for the purpose to make a stronger dialogue with the stakeholders on the right hand side. So that is probably the additional work to the very scientific work on Kuroshio. So CSK-2 can be one of the UN decade program developed by IOC-WESTPAC. And what we need to consider, maybe I think we have 2 points. One is the Kuroshio Science to Society. So I would like to ask all PIs to consider relations with decade outcomes. We now have 7 outcomes. And second one is maybe we still do not know how to do that, but we have to consider how to co-design and co-deliver with partners and stakeholders. And we need to try to develop the value chains. So value chain include the data information service systems and Kuroshio literacy. Yeah, thank you very much. This is my opening talk.
Thank you, King. Yeah.
Yeah. How to stop okay, this one, yeah. Stopping data sharing has stopped.
Yes, it's stopped.
Okay, okay. Something wrong. Okay, yeah, thank you very much. Yeah. Yeah, that's all, yes. So I want to have some questions or comment on my opening talk. So if you have questions, please raise your hand. I think we have a button. Oh yeah, Chung-hyun Nam, please.
Oh yeah, it works. Okay, I tested the raising hands.
Okay.
Actually, I have one question for you.
Yeah.
I was informed of the CSK-1, the original CSK, was the first international program of the WESTPAC, and it was very successful.
Yeah.
That is what I heard. So could you share any lessons learned from this original CSK? Because we are now facing, visioning the CSK-2, and the situation is quite different from the situation we had at the time. So could you briefly introduce the CSK-1 and the experience and the lessons learned from that regional program?
Oh, I think this will be already written in the review report submitted to the Progress in Oceanography. But yeah, in my understanding, for example, in Korea, you could establish the Korean Oceanographic Research Institute through the CSK. And also in Japan, we could develop the Kuroshio data centers to support the Kuroshio science. So that was the egg of the Japan Ocean Data Center, in my understanding. And also, of course we had the some scientific achievement. For example, the Kuroshio recirculation system, I think, or some several scientific achievement. Such kind of things. And also in Japan, we could have the some chemical standard waters. We could develop some chemical standard seawaters for the measurement of the chemical variables. But in general, speaking, the CSK was the basement of the regional collaboration of the WESTPAC. WESTPAC was born in 1989. CSK finished in 1979. So after the ending of the CSK, we needed 10 years to establish the WESTPAC. So the most achievement of the CSK was the establishment of the regional body of IOC. So sorry, I do not have the enough information here, so I could not say in detail. But
thank you for answering my question. And I'd like to mention a little bit more on the recent change in the CRIMS, AP CRIMS under the PISHIS program. So originally we focused on the marginal sea in the Western Pacific, specific marginal seas, the East Sea, Japan Sea, and Yellow and China Sea only. But now for extended term, we broadened our scope to include all the Western Pacific marginal seas. So I believe the Kuroshio impacts some the environment in the marginal seas in the Western Pacific, and this CSK-2 have interest in the exchange between the marginal sea and the Kuroshio, as well as the Kuroshio itself and its branches. So I think the CRIMS can be part of this. I mean, CRIMS can closely collaborating with this CSK-2 program.
I think so. Yes. So I don't know what kind of shape we will have for the CSK2, but mainly probably the at least at the core part of CSK2, we will have the we will try to understand the Kuroshio from the origin region through the east part of Taiwan and going into, or some part going through the east of Okinawa Island, or some part going into the Eastern Sea, and then go through the south of Japan. And this part will be, I think, the core part. But of course, we will have the another important regions, and then this part we need to collaborate with the other international partners and activities.
Thank you.
Yeah. So any other question?
Ando-san.
Yeah.
Yeah, just wondering when you mentioned on your slide about the you try to link between scientific and to the community, and it's meant to the society, something like that. And do you have any idea what is how we could able to communicate? I don't know what kind of language, something like that. We can would be the best way for achieving this target?
Yeah, I think, yeah, for the dialogue with the stakeholders, it is important, but still in the implementation plan of UN decade, these are not clear, it's not clearly mentioned yet. And I think the dialogue with the stakeholders need to be done at the national level at first. So, for example, Japan may need to establish such kind of the framework for Japanese, stakeholders, and China also, and Korea, Philippines, Indonesia. So that is one way. And at the same time, maybe we need to consider using the WESTPAC framework to have a more broader dialogue at the regional scale. So, for example, by using the WESTPAC conference or some kind of the international meeting, we may invite the stakeholders who are related to the main topic, and we may discuss.
Okay. Thank you, Ando-san.
But in my sense, for the dialogue with the stakeholders, maybe this should be mainly done by member states, each member state, by country. So by using their local languages.
Yeah, I agree with you. And we can also use the WESTPAC as the big umbrella for
Yeah.
I can, if you allow me, can I make some comments, or based on Andrew's question, how to collect science to society. I think the key words for UN Decade of Ocean Science is to collect science to society. So the key action is how to promote solution-oriented research. Solution-oriented research. For instance, in the case of Kuroshio, so most of us understand its role in the regional climate system, right? In the marine productivity, right? And also in marine environmental protection. Those kind of societal outcome or concerns. So we need change. I think the current the UN Decade encourage scientific community, to jump out of the comfort zone. I think scientists, as you understand, they are very much get used to the comfort zone they have now, working on science, publish paper, even regardless of what the scientific input will be, or how to contribute to addressing, those kind of societal outcomes. So this is the key point. I think the UN Decade want to advocate, and also this is also key direction that the CSK would like to move forward, right? So for the CSK-1, you can say, CSK-1 starting from 1965 and terminated in 1979, 14 years, very much based on the design, the whole design very much based on individual discipline, oceanography, physical oceanography, biology, chemical, these kind of things. But we cannot just, at that time, of course, I think the CX-1 made a tremendous contribution to the national and the regional capacity for marine scientific research. But 30 years later, now UN Decade, we have the good opportunity of UN Decade, and the whole international community really wish to, to bring some behavior change, to our marine scientific research through connecting science more closely to society. So this is the substantive point. I think, we wish to see that change that can happen, over the next 10 years.
Yeah.
Right.
Yeah.
Thank you,
But Vinci, I think the behavior change by expert cannot be done very quickly. So I think we need to, promote the change slowly, right?
Yeah, correct. It's not easy. I think it's not easy. It's a formidable task for any community, not only marine scientific communities. But the initial change are expected to happen with the scientific community first, right?
So in this webinar series, we started from the science-based talk, and then we try to seek how to find the way to contribute to the society, right? I think this is a way. I think we see.
Okay.
Yes.
Yeah.
Yes. Mm.
And also, if possible, Ando-san and Wensi, maybe there were some kind like a policy brief coming out from our CSK-2 webinar. It will be very, very useful. Science brief, when policy brief mean is we try to communicate, produce some kind of paper that easily understand by the, let's say, the policy maker people or the ordinary people, something like that, about what is going on in this CSK-2 subject, something like that. Just, yeah.
Okay, thank you very much. Wensi, I think this kind of dialogue should be done during the WESTPAC International Science Conference, right?
Not only, I think at many, not only, at many, possible occasions. We have to work first with the policymaker. I think I think it's the most important stakeholder for those scientific program, right? And the policymaker also need to listen to the opinion from fishery community, right? From those kind of climate related stakeholder. So I think from beginning it's important for us to have that kind of a mind, and then start to consider how to design the CSK-2, to align CSK-2, to closer to the needs of society.
Okay.
Very good discussion, I think so. No.
Yeah. Thank you very much. Maybe but this webinar series until the end of August, we first try to focus on the scientific plan first, and then we're gonna move to the how we will have a policy brief by using the correction of the science plan. This is that's kind of my
Science action plan. Science action plan. Yeah.
Yeah. Thank you very much. So, any other comments? Hiroaki-san, Saito-san. Yeah.
Okay. Thank you, Ando-san. Thank you very much. Very nice talk. And I think we have very, very big difference between CSK-1 period, 1960s, 70s, and CSK-2 or 2020s. Is a very, very different technology we have. Now we have glider, algo, very nice equipment, research vessel. We have many, many research vessels, especially China, Korea. And we have more capacity carrier science, ocean science. The other difference is we are very, very familiar with international collaboration in science. But for ocean science, especially coastal area or Kuroshio current area, Kuroshio pass through many, many national jurisdiction area or EEZ. And international collaboration in EEZ is nowadays not very easy because of the several reasons. I think Ocean Decade, or developing new project, CSK-2 under Ocean Decade, is a very, very nice opportunity for us to carry out international collaboration in each member country. Sometimes we are not very easy to get into the EEZ of other country. Even this is a very important area for Kuroshio current or Kuroshio study, that we can develop very unique and coherent observation in the project, and we can exchange information, and also we can invite scientists to get on the research cruise on within our national jurisdiction area. So I think this CSK-2 and the Ocean Decade is a very, very nice opportunity for marine scientists. And this is based on our producing the nice result or finding of the CSK-2, we can prepare nice, very good evidence to make decision how to use ocean marine ecosystem or marine system in sustainable way, I think. Okay, thank you very much.
Thank you, Hiroaki-san. Yeah, I fully agree. And also, as well as the advancement of the observational technology, we also have the advancement of IT technology, which is much different from the, the information exchange since the CSK. And so the full use of new technology of information, it is also maybe we need to consider as an infrastructure of the to promote the CSK2. So maybe the after this webinar series, I want to have the special webinars focusing on the data, information, and service issues for CSK2, maybe in future. In September or October, maybe during the writing of the Science Action Plan. And then we exchange how we promote the data and information management system for CSK2. Yeah, that is my idea. So thank you, Hiroaki-san. Any other question? Okay, if not, so thank you very much. I would like to move to the first webinar's science talks. First one is Don Liang.
Okay. Let me put on my I'll share the screen and can everyone see see my screen now?
Yes.
Okay, now I'll start. First of all, let me thank Endo and Xiaopei for inviting me to the webinar series, and I also want to express my gratitude to all Indonesian collaborators who has made the investigations measurement inside the Indonesian seas possible, especially former Director Zeno Arifin, who has been very supportive to our study. The title of my talk, of our talk, is The Role of the Western Tropical Pacific Ocean, including its interactions with the marginal seas in ENSO dynamics and global climate change. This work has been collaborated with a couple of people, but I only listed some of the major collaborators. This is the outline of my talk. I'll first briefly review the Western Tropical Pacific Ocean study, and then move on to the three-dimensional and multi-scale processes and its role in the ENSO and global warming. And finally, I'll talk about our program design of the Indonesian seas measurement. The importance of the Western Tropical Pacific Ocean is because it's associated with ENSO, and we know that ENSO starts from the Western Pacific and has global repercussions. But in the past, the observations mostly has concentrated in the Central and the Eastern Pacific Ocean. In the far Western Pacific Ocean, where the Western boundary current and the Indonesian seas interact, there's basically a data void. But this area is important in determining the ocean convection, and atmospheric convection, and moisture transportation over the Asian continent. So it's very important. And historically, since maybe a century ago, we collect the data from the upper ocean, from the ships, and then we understand roughly the upper ocean circulation. And then it is the CSK that give us the first glimpse of the western boundary current, particularly the bifurcation of the North Equatorial current into the Kuroshio and the Mindanao current. Their interactions with the marginal seas is very important for the understanding of the regional circulation. But after that, oh, by the way, the regional circulation we understood mostly is from the ship drifted data, and that's not much measurement historically. So based on this measurement, we understand that in the Western tropical Pacific Ocean, basically the tropical Pacific Ocean, we have the South Equatorial current, North Equatorial current. We have the North Equatorial countercurrent in between, and the Equatorial undercurrent below the South Equatorial current on the equator. Then we don't know much about the three-dimensional circulation. And later studies suggest that this area is very complicated, even in the surface circulation. And we named it the small triangle between the NEC bifurcation, the Equatorial Pacific, and the Equatorial Indian Ocean. The signals from these three major sources intertwine, and generate a lot of variabilities to the warm pool of the Western Pacific. And then from the after the CSK, we have the Toga, we have the WOS, and then we have the hiatus of nearly 15 years, during which we only have like satellite observations and algo measurement. And then the beginning of the NPOS. Through this process, we started to understand the 3D structure and the multi-scale variability of the Western tropical Pacific Ocean. And we understand that there's signals through the ocean channel between the Pacific and Indian Ocean. They interact and impact the global climate. And in the surface, we understand there's this complicated interaction between the Western Pacific Ocean and the marginal seas. And below that major current, we have identified a number of undercurrent and a number of western boundary current. So we try to understand the dynamics of this subsubalcline current, how it was generated and why it is there. Using the mooring measurement during the NPOS period, we were able to observe directly the undercurrent below the Kuroshio, which is called the Luzon undercurrent, and the current undercurrent below the Mindanao current, which we call the Mindanao undercurrent. And Professor Hu has led a review paper on the Western Pacific Western boundary current study. But needs to be mentioned that this current, the average of the mean current is still not statistically significant over multiple years of observations. And another very important is the North Equatorial current and its undercurrent. And this was mostly extensively studied by Professor Chiu Bo of Hawaii University. And he used geostrophic calculation to show that below the NEC, there are multiple courses of the undercurrent that flows to the east. And this current has been directly observed by the NPOS subsurface mooring arrays at along 130° east, which shows clearly eastward current below at about thermocline. So this current is very outstanding. This phenomenon is very outstanding, and Professor Chiu has used the linear model, a 1.5 linear model, non-linear model, to suggest that this current was forced by the eddies generated by the triangular instability of the Rossby wave interaction near the eastern boundaries. But I think that people still have questions about the dynamics. Number one, this 1.5 linear model didn't really simulate the subsubalcline character of the current. And the model, you can see that simulated current stronger in the east than in the west, because the eddies first generate in the east and propagate to the west. But in the observations, it is stronger in the west. And the Eastern Pacific, particularly near the eastern boundary, the circulation are not very much in agreement with the model. So the tacit assumption that if we add one more layer, then perhaps we will be able to reproduce this subsubalcline circulation using the 1.5 linear or 2.5 linear model. But actually, unfortunately, this doesn't work So the theory of the thermohaline circulation suggests that when you have a 2.5 layer and there's no outcropping of the subsurface layer, then you have the surface gyre circulation driven by the Sverdlov dynamics. And then you have the subsurface circulation. Their potential vorticity contours are connected to the eastern boundary. So that because there's no vorticity input into the second layer, so these areas are stagnant. These are called the shadow zone. So only in the closed contour area, which is homogenized by the eddies from the western boundary current, that waters can move. And you can add more layers onto this model, and you can have smaller area of a movable circulation in the lower layers, but you will not be able to produce the circulation inside the shadow zone. And even the LPS model with the outcropping thermocline shows that you can only have steady state movement on the ice-picnal surfaces that outcrops to the mixed layer, so that you have Ackermann pumping of vorticity into the subsurface ice-picnal surface layer. And then only those layers you can move. Next to the eastern boundary and in the large area of the tropical oceans, you don't have steady state circulation that is allowed by this theory. So, but 1.5 layer reduced gravity model do not have this shadow zone, of course. And if you have more layers, you will produce the shadow zone. We know it will extend to the western tropical Pacific Ocean. So based on this, we claim that the dynamics of the subthermal currents are probably not consistent with the 1.5 layer or 2.5 layer reduced gravity model. Now, the impulse period, we have identified a new current called the North Equatorial Subsurface Current. This is based, first based on the absolute geostrophic current calculation using the p-vector method, which is basically the beta spiral method. And we were able to identify the undercurrent below the North Equatorial countercurrent and below the thermocline. And you can see that the North Equatorial current below that, there is an undercurrent. And they have a weak core structure, but not that strong. So the core structure basically produced by the reference level problem. And if you look at the shipboard ADCP measurement of the historical measurement, a lot of shipboard ADCP, you see that next, north of, so first only between 2 degrees and 70, you have the Chuxia jet that flows from the Western Pacific to the east, very strong, which is basically extension of the equatorial undercurrent. But north of it is a westward current that's flowing to the west, which that's what we found the North Equatorial countercurrent. And that current has the SEDCP has a measurement about over 6 centimeters per second, geostrophic current about 4 centimeters per second maximum, transport about 4 Sverdlov in the Western Pacific, which is significant. And if you look at the sections of 165, basically at the center of the wormhole, you see this westward current below the NECC flowing towards the entrance of the Indonesian seas. And fortunately, my colleagues has a mooring at 4.7 degree north, 140 degree east. He was able to measure this westward current directly using direct measurement of the current. And we noticed that Bochu's geostrophic calculation relative to 2,000 meter of level of no motion indeed has shown this westward current. But because this 137 east hydrography section is only 2 times per year or 1 time per year, so I think he probably didn't realize this is a mean current. We noticed that during the 2015-2016 strong El Nino, the NESC is much weaker. And my colleagues are so fortunate that he was able to even measure this current so strong during the even ENSO period. And then actually during 2016, after the ENSO, the current getting much stronger. And you can see that here is much stronger. I'll show a connection to the Indonesian through flow later. The water masses of the NESC appears to be the mixture between the North Pacific intermediate water and the South Pacific tropic water across the front, but they have a very organized TS curves are distinctly different from the South Pacific and the North Pacific waters. So now what's the dynamics of the of this undercurrent? You have the NESC, you have the NEUC. So we propose a continuously stratified model with a flat bottom to explain the dynamics. So if you have a linear continuous stratified model, you separate the variables, you have the shallow water equation model like this, and the vertical structure is determined by the Sturm-Liouville eigenvalue problem. And each eigenvalue is the wave speed, gravity wave speed of that baroclinic mode, and the eigenfunctions, which is the psi n, is the baroclinic mode functions. Notice that in each of the shallow water equations,
Dong-Liang, is your microphone okay?
I think something wrong with Dong-Liang's connection. Huh?
Well,
I will try to make a phone call to Dong-Liang.
Yeah,
suddenly drop.
Dong-Liang, can you hear me?
Okay, just wait a moment. And Dong-Liang, no, we can't hear you. No, 您的麦克现在显示是静音，是被 mute 了。
No, microphone is on.
没有，您现在是麦克已经打开了。您再说一下。对，但是您说话我们还是听不见，没有，我只在电话里听到您的声音。
突然一下子，不知道为什么。
No voice, no voice. No voice.
Okay, so please just wait 1 minute, and Dong-Liang will re-enter the meeting. And his voice, there's something wrong with his voice.
Right. So Ken, taking this opportunity, I think something we can think about, in the case of Dong-Liang study and pulse, and also thinking about the objective of the UN decade, the Ocean Decade Challenge. How this kind of program could be, aligned with the UN decade objective, better aligned. There's tremendous efforts has been made, in this region in terms of observation, process analysis. But I feel a little bit weak in, developing solution. And also, to improve service, the climate or ocean related service. So this is something I think if this program can, can demonstrate, improved service. Still cannot hear.
Cannot? Wow.
Okay, I will make a phone call to Dongliang.
Okay.
Oh,
no, I cannot hear.
I can just hear.
How about the Xiaopei? You call to Dongliang and then.
杨老师，不是网络吧？我
好吧，我现在音响显示的在显示，他能听见吗
？Xiaopei, we can hear the Dongliang's voice, so maybe he will continue his presentation through your.
Yeah. I just use my phone to connect with Dongliang, and he can talk through my phone.
No, I think the internet have collected my voice.
Yeah, but please share the Dongliang's. Maybe they share the screen.
Dongliang, could you share your screen to us?
Then.
Okay, yeah, Dongliang is sharing.
Dongliang can talk to the phone, and then we can hear your voice.
Can we talk this way now?
Yeah.
Okay. Let me from the beginning of the model. So if we have continuously linear stratified model, we separate the variable. The horizontal circulation would be governed by the shallow equation, and the vertical structure is governed by the thermodynamic system of a larger value problem. And because of you have the bottom boundary condition, each eigenfunction has a fixed structure. And you have the first mode, you have the second mode, the third mode. And if you only superpose the three mode, you were able to produce the undercurrent below the NECC and NEC. In addition, you can reproduce the EUC and the 3CX at the equator. And if you superpose 10 mode, of course, each mode has to be divided by the equivalent depth, because after that, all the shallow water equations are the same. And then you produce the undercurrent nicely on the equator and in the Nordic Pacific Ocean.
Dongliang, everyone can see the screen by Dongliang?
No.
See my screen?
Yeah.
Xiaopei, did you see?
Yeah, I also can't see Dongliang's screen.
Oh.
I think it's a little bit strange. From screen, seems that Dongliang already started screen sharing, but we cannot see. I think it's some kind of internet connection problem. It's very slow, maybe, at Dongliang's side.
I think you can see my face, right?
No.
We cannot see your face either.
Oh, that's strange. I can see myself waving hands in the. I think let me leave and read. Let me try again, okay?
Yeah, okay. Maybe this, if it takes time, maybe we move to the Xiaopei's presentation first.
Yeah, we can. I mean,
okay, so maybe I will talk first and then you talk later.
Yeah, maybe the Xiaopei first and then Dongliang later.
Okay, so hello, King and everyone. Could you hear me?
Yes.
Okay, I will share my screen. Okay, so could you see my screen?
Yes, very good.
Yes, yes.
Okay, so, okay, good afternoon, everyone. My name is Xiaopei Lin from Ocean University of China, and today I will talk our ongoing work about try to set up the integrated observation and the service system in the crucial extension region. So first, I will start with why we choose the crucial extension, because this is a very important western boundary current region and with intense air-sea interaction, and from like the figure in the upper middle, we can see there is a huge heat release from the ocean to the atmosphere. And in the upper right panel, this is what's so-called subduction rate and all the mold water formation. We can see this is also a key region that for the memory of the ocean and climate, because mold water will save the information about the atmospheric forcing or nutrient or other information to the surface of the ocean. And also this region is full of the biodiversity and is also a key region for the carbon sink. So that's why we first choose the crucial extension. And so previously there are several observation programs in this region, like the first is in 1987 by the Soviet Union, and later is by US and Japan, the CSK-2 observation plan. And later, a very famous project is the CAS project. The CAS project, I think, maybe the first intense observation about the crucial extension region, and especially we use like subsurface mooring and sea pies, and to observe the crucial extension. And later, there is a hotspot that's I think is a following up of the CAS project led by Japan scientists. But the hotspot is just ended in 2014. And recently I heard good news that the Japan will start the hotspot 2 and the next phase. And so currently and prior to 2014, there are still several stations that maintain in this region, like the GKU buoy and NKU buoy, KU buoy, and also a subsurface mooring, the jump stack BGC mooring. But after 2014, there are only a KU buoy maintained by NOAA and still here. So there are lack of the long-term and institute observation. And one of the reasons that why in the crucial extension region, as well as in other mid-latitude region, the observation is so rare, because in this area, especially dominated by the westerly wind and the storm and waves and severe sea state, make it hard to make this institute observation. And here I just show you the movie. This is our people that try to deploy something in this region. And especially, I think, in the Pacific Ocean. Here I show you two figures just from our white paper submitted for the Ocean Ops 19. In the left panel is Atlantic Ocean. And we can find there are many glider and the time series. The time series means like buoy or mooring or other long-term institute observations. And in the right panel is the Pacific Ocean. We can find in the crucial extension region, there are very few observations. There is no glider observation and only very few time series. And also the time series here, I show you the time series here is by the KEO and also by our buoy and moorings. So now we have an international project under the IOC-WESTPAC, the air-sea interaction in the crucial extension and its climate impact. This is started from 2012 and led by our university and Texas A&M University. And we also involve many scientists around like Korea, Japan, and the US and European, and also from China. And we try to make a continuous and sustainable observation in this region and to understand the multi-scale ocean dynamics and air-sea interaction. So the key scientific issue I summarize here is, like first, we will focus on the mold water subduction because the mold water is what we call the climate memory. And we also focus on the feedback between the ocean mesoscale eddy and the atmosphere, and especially their interaction, because we find this is important for the mid-latitude air-sea interaction. We also focus on energy exchange between the internal waves and mesoscale eddies, and this is one of the important energy cascades that maintain the mixing in this region. And also we focus on dynamic dipychno mixing and in the interior, and so also the submersible processes and its influence on the dynamical and biochemical property. And I just show you this what we have done in the past 5 years. And this project, especially I want to introduce Dr. Zhao Hui Chen. He's also in the webinar now. He's our leader, chief scientist, and leads the major cruises in the past 5 years. And we have 6 cruises from 2015. And now you can see besides the KEO, we deployed 2 buoy now and 4 subsurface mooring. And especially now the 4 subsurface mooring is also real time. And this is the buoy, the CKU and the CKU-A deployed by our team. And this is data just transferred from the buoy in the recent days. And we can find this 2 buoy works pretty good and can get many data for like the short wave, long wave precipitation and carbon dioxide and other parameters. And this is a position and for the 2 buoys, and also the system temperature, system salinity, and also the velocity. And here, especially in the buoy, we also deploy the 300K ADCP, and so it can measure the upper 100 meter velocity, and so you can transfer data in real time. And I just show you the data in the past 1 month. And besides the surface buoy, the 2 surface buoy, we also have 4 subsurface real-time mooring. And for the real-time mooring, we equipped with like the TD, CTD, ADCP, and the current meter. And this is a basic design for the subsurface mooring. And this is data come back from the subsurface mooring M1. And the upper and middle panel is observed current by the ADCP and the current meter. And the lower panel is observed the temperature. And it also show you the data because this mooring is deployed at first in the 2016. So it's now provide the data for nearly 4 years for the mooring M1. And this is for mooring M2. It's deployed later, so it provide about 3-year data. And this is M3 and deployed in 2018 first, so it provide about 2-year data. And this is M4 and deployed just in last year, so it provided less than 1 year data. So all that shows that we can now get the real-time information of the ocean, not only from surface, but also from the subsurface ocean. And besides, we also test several mobile platforms like the Deep Argo and Glider and Surface Drifter and Wave Glider and in this region. And we try to build an integrated observation system, both for this fixed station like buoy and mooring, as well as mobile platforms. And this is one of the drifting that we deployed in the past 3 years. And this is a track. And here I will show our future plan. And now this is what we have in the crucial extension region. Now we will have the KU buoy and also the CKU buoys, and besides, we will also for subsurface mooring, and we plan to have this cross-front real-time and in-situ observation, and to make it as long as possible, and along with some observation from the mobile platforms. And the key issues that we will first focus on the crucial extension gas meander and eddies, and also the multi-scale air-sea interaction, and as well as ecosystem and fishery associated with the ocean dynamics. And also in the future, we wish to discuss with our Japanese and US friends and to see how we can work together and to maintain the system to make service to the public. So last, I want to talk what we have done and its linkage to the UN decades. And I just show the 6 route maps here. And because the crucial extension region is a key region, first is for the ocean environment. So if we can gather enough observation, especially we can gather real-time data, it will, I think, important for us to make this to monitoring the environment in this region and to help to make a healthy and clean ocean here. And the second, why we always emphasize the real-time observation, because if we want to have a predicted ocean, the real-time observation is important. So our purpose is also that our real-time data can serve for the operational predictions system, and also we want to work with the scientists and from the different country and try to set up like a transparent and accessible ocean. And so all our data in the future will open to public, especially the real-time data, because the real-time data is valuable that for the like the stakeholder and the public to use and to know the ocean condition, and also to make some decision, and also to so this, I think, is what we link to the UN decade. So I just want to stop here. Thank you, everyone.
Thank you, Xiaopei. So maybe for the question, please also use the chat for asking your question to Xiaopei. So if you want to ask something to Xiaopei, please raise your hand from the participation list of participants. So no question? Oh, many. Andreas.
Many.
Sorry, Andreas first, please.
Okay.
Yeah.
Thank you. Very nice, and interesting presentation, Shopping Lin. I just wondering, I mean, how you could translate your observation, your finding into simple, I mean, what we call it, like a policymaker to understand that your study is very useful for them, something like that. Because we know here that this is very, very sophisticated data, abundance, information inside, but can you summarize us that how we could able to link your data here to any of the question from the ocean decade, something like that? Thank you.
Okay, thank you, Andreas. It's a good question. I think it's hard that, like, if I just show, yeah, this figure to any like policymaker, he can understand what is the meaning. So one of the things that we think how we can transfer our data and to what the public policymaker or public people that can understand is maybe we can through the prediction system. So that's why we are work closely with the people that for the like the weather prediction or the ocean prediction, so they can use the real-time observation and to give a better monitoring of the environmental and weather in some region, and that's show why we have this kind of observation. I think this is one way, and another way that because sometimes maybe from our real-time observation, like the buoy data, they can directly see some parameters like wind and wave and precipitation, and especially if there are some extreme event, they can see this event and directly. So, but anyway, I also have currently I have no very good idea, but from my view, I think it's better that we collaborate with some operational system or operational maybe company. Yeah.
Okay, thank you.
Thank you. So next, Wensi, please.
Oh, thank you, Ken. Thank you, Xiaopei, for this wonderful presentation. I think my comments or impression is quite similar to Andrew's. I think this is something we need to think together and how to move forward. You see, how to ensure this data information could be translated into knowledge, and those knowledge could be used by end users. So as I said, this is the point, this is the key point of UN decade. So from beginning, we need to understand what kind of societal concern and how to address those societal concern by conducting those observation process study and also observation data and model development. And then go to the user again as a service. So this is the kind of full value chain, as Ken mentioned in his introductory talk, from end user and to end user. And then in the value chain, we can say, the scientific community needs to demonstrate the essential role in this value chain process. So I would very much appreciate, Xiaopei, I think a lot of work has been done. If you can have a clearer picture about what end user you plan to serve and what kind of product you plan to, not only you, or you work with other group to generate the product information or knowledge service to serve that end user. So that would be fantastic. I think this is something we have been discussing. Can show there are totally 10 ocean decade challenges. Some are issue-oriented, societal issue-oriented. Some are capacity infrastructure oriented. I think this says your presentation has served the purpose of several ocean challenges already. The key point, the key challenges, how to better link, your science work with other users, and also, by produce more tangible outcome or tools for users, right? Andreas, this is something I think, you also want to say clearly. Yeah, Xiaopei, this is my suggestion,
Yeah, thanks, Wenxi, and also thanks, Andreas. And this is our weakness for the ECIC project at first, and now we are working towards to push our data and result to the end user. And here, like I show you this purple, the upper left panel is one of the possible ways that we are working with modelers and try to help them to build this like forecast system, and so they can use our observation data. And especially, we experience a severe flooding in China, and both in China and Japan. And one of the possible way is change like the mean state of the ocean in the recent year, and something like this, so that what we can help them to do. And also we try to make some collaboration with some fishery people, and because the fish are very sensitive to the environment, like the temperature, and they wish we can help them to give a prediction of the ocean's temperature, and so they can help them to maybe predict the fishery catching and something like this. But you are right that we need to, maybe in the future, we need to first to think clear, and also figure out what the end user requirement and what they want, and so that can fit into our science study and also the observation.
Thank you, Xiaopei. Maybe next question is by Sun Hyun Nam, Seoul National University, please.
Oh, yeah. Thank you, Ken, and thank you, Xiaofei, for nice presentation. I think it's also related to Wenxi's comments. I think one of the contributions of this new observation system in the Kuroshio extension area would be the capacity building and for ocean observation, especially, and I agree with you on the importance of real-time observations in the Kuroshio extension area. But at the same time, the archived data of a long multi-year time series data are very valuable to better understand the process and to better predict the Kuroshio and other circulation. So my question is, I think your intention is to establish this new time series observation sites in the Kuroshio extension. So my question is whether this observation system is already part of this global network of the observing system, ocean sites, for example, or not. So do you register these sites to ocean sites and provide the data already?
Oh, okay, yeah, very good question. Some of stations we have pre-registered in the ocean site, but currently we are still do not provide the data, because you can see, especially for the surface buoy, we are just deployed in the recent 1 year, and we are still for the data test and the quality control test, and we are working closely with NOAA and other people, and to study from them to how to make the data to meet the quality of the ocean site. And for the subsurface mooring, because the real-time technology is also newly developed, and we are also working on this, the data quality control and also the transfer technology. And if everything settled down and we pass the quality control, and we will submit all the data maybe through the ocean site or other public ocean data center. In fact, the CKU is pre-registered in the ocean site now.
Okay, thank you very much. And that would be one of the good examples of the contribution to the UN Decade of Ocean Science, I think. Thank you.
Thank you. Next is Donian, please.
Everyone can hear me now?
Yeah, sure.
Yeah.
Okay. Xiaopei, I missed the first few slides, maybe more than a few slides of your talk, but it's a nice talk. I guess when I come to the end, I have a strong feeling that, or I have a strong question. I think several of the previous questioners have already asked is that what's the purpose of this observational mooring constructed for? I mean, if you construct such a kind of a mooring in the western boundary current, I understand that you're trying to capture like some kind of ocean phenomenon or air-sea interaction that is not resolved by the current observational arrays. But right now in this Kuroshio extension, it is pretty well covered by the Argo float and was well measured by the satellite remote sensing measurement. So, and you just want to make a repetitive measurement, or, I mean, you understand that OutCast has a lot of mooring in the Equatorial Pacific Ocean area. I also question them, what's their purpose to maintain a longer time series over there, given that it's so expensive and so difficult to maintain for long-term measurement. So maybe you can shed out some light on this.
Okay, yeah. Donna, yeah, you asked a very good question. Why we want to maintain, spend a lot of money and time to maintain the first reason I think is there is a full of multi-scale ocean and the air-sea interaction variability here, which is not well resolved, both by Argo or by satellite observation. For example, in this region, this is a key region for the eddy-induced air-sea interaction. It's also now confirmed to be one of the most important air-sea interaction in the mid-latitude. But even now, the satellite observation cannot resolve it. And also because there is no direct like flux observation. So for the only satellite data observation and use like a bug formula. So the mid-latitude air-sea interaction is still an unresolved question. And another reason that we want to keep this observation here is also there is full of like submeso scale ocean variability. Although our observation is not intensive now, but it has a good resolution for the time, especially like we have the ADCP and it can monitor upper layer along with other observations, and we also try to resolve the submesoscale or even high frequency variability in this region because this is a strong front area. And also, besides, in the future, both the surface buoy and surface mooring will equip not only the physical sensor, but also the biochemical sensor, so that they can serve for the ecosystem. Because this region, as I show you in the first slide, here is also the major carbon sink and also for the very important biodiversity region. Okay, I think this is why we want to maintain the observation in this region.
Okay, so next question is Jihad, please.
Okay, thank you, Shafi. I have some practical questions on the moorings. The first one is that how do you manage the sensors installed in the buoy? The second question is that what satellite system is used for the data transmission?
Okay, so hi, Jack. What's your first question?
So how do you manage the sensors installed in the buoy?
Oh, you mean how we,
for example,
sensors.
sensor calibration, something like that.
Okay, okay. Because I think maybe John Hui can answer your question for the first, but I just maybe and also for the second question, I just know some of this. Like we use the Iridium satellite to transfer the data back, and for for the buoy sensors, before we deploy, we do some collaboration in our lab. And so Joey, could you add something about how we collaborate?
Okay.
With our sensors?
Okay. Thank you, Jack. Most of the sensors on the moorings, particularly on the subsurface moorings, are 1 year deploy and update. So we have the CTD data, CTD sensor to be collaborated before the next deployment. And most of the sensors, such as the CTD, is the newly from the factory. So before deployment, all the data, all the sensors have been collaborated well. Yes, you're right. Maybe some year later, the ADCPs or other sensors may be facing a problem, whether the data is good or not. So we in OUC, we have a newly built kind of data collaboration laboratory for our sensors collaborations in the next year. So that's my response to Jack. Okay.
Okay, thank you, Joey.
Yes, thank you. So, Jihak, are you okay? So next question is the Lin, please.
Okay, so I think it's a very nice talk, but I just have a very simple question. So do you have any MSR clearance issue in this area?
Currently, I think no, because this is usually in the open ocean, and especially our station is, I think, is not in some easy zone or something like this. Am I right, Joey?
I'm sorry, can Lin repeat your question?
My question is it your mooring in the EEZ or
okay.
of Japan or
yeah? Actually, the science has no international boundary, but actually we are afraid of being some potential problems associated with the EEZ problem. So all the moorings, including the buoys, have been deployed to the east east of the EEZ of Japan, which is about 230 nautical miles away from this line. So this is actually the open sea for the Western Pacific. So my question.
Okay, because
yeah.
So the reason that I ask this question is we have such kind of problem in the western boundary area. So just in this May, so Caesar is here. Caesar just help us to recover our mooring in east of Luzon Island. So okay, that's good that you do not have this problem. Okay, thank you.
Thank you. So any other comment or question from the floor? So I have a question to the Xiaopei. So does your buoy transmit the data to the GTS by WMO?
No, currently no, because we, as I mentioned, we still need to pass the quality control, and then we can transfer it.
But the WMO also has the quality control system, so you can send even the low quality data to GTS. It's no problem. Yeah.
Okay.
And then you're gonna have the WMO numbers. It is really a first step to contribute to the predicted ocean in UNDK.
Okay. Yeah. Very good suggestion. And we will.
That's good. Good suggestion from Ken. Yeah. We're gonna have build a data quality control team this year or next year, and all these data can be uploaded to the GDS in the near future to get the WMO numbers and to share all the quality control data to the world. But as Xiaopei said, right now, currently we have no capacity to make all the data available before good quality control. That's all we are now trying to do this time.
Yeah,
Thank you.
Maybe each country has a the gateway to the GTS, and in case of China, I think CMA has a gateway to the GTS, and maybe the CMA will help you to do, I think. And
Yes,
another question is this, to the Xiaopei, is that if do you have a plan to install the surface wave sensors or some sensors related to the marine ecosystems in future?
Okay, and
Okay.
yeah, Zhaohui, yeah, I think you can.
Yeah.
Zhaohui?
We cannot hear.
Okay, so yeah, currently we don't, I think we don't have the sensor for the surface wave, but we will consider to add this. And so your second question is there any observation in marine threat?
Marine ecosystem. So
Yeah.
biogeochemical sensors.
Oh yeah,
biological sensors.
Yeah. We plan to add some sensors and to this, and in fact, like in some buoy, we already have the sensors to measure the carbon dioxide, and also we will try to add more biogeochemical sensor in our like subsurface mooring and also in the buoy. Yeah.
Okay, thank you very much. Any other question? If not, Xiaopei, thank you very much for your presentation. So
okay,
we move to the Dong Liang's one. So please continue your presentation. Yeah, Dong Liang.
Can I start from the model part?
Yes, model part, yes.
Okay. Everyone can see my screens, right?
Not yet.
Not yet.
Not yet? Oh, I'm sorry. I haven't shared the screen yet. Sorry. But you can hear my voice. That's good news.
Okay. Right.
You can see the screen now?
Yes.
Yeah.
Yes, we can see now.
Okay. Now, let me put on the
Full screen mode, please. Oh, yes.
Yeah. So, I guess I'll repeat several times. I'll move faster. So, continuously stratified linear model, you can separate into horizontal shallow water equations multiplied by vertical mode functions. The forcing terms in all the shallow water equations of every Bernoulli mode is the same, except that the forcing term is divided by the equivalent depth Hn. So if you divided the Hn to the eigenfunctions of the Bernoulli mode, then all the solutions of the Bernoulli mode shallow water equations are the same. So the superposition of the Bernoulli mode function determines the vertical structure of the gyre circulation. And we have produced like the first 3 mode and the first 10 mode of the superposition of the first few Bernoulli mode. And you can see that the low order Bernoulli mode, their superposition can reproduce the observed undercurrent well. So now the difference of these shallow water equations, the continuously stratified model from the reduced gravity model is that we have a bottom boundary, which says that the velocity must be 0 at the bottom. This is a flat ocean. And this determines that the ocean has discrete eigenvalues and discrete eigenfunctions. And that is very sensitive to the stratification nearby the thermocline, and that decided the Bernoulli functions, the sub-thermocline structures of the ocean current. So there should be no shadow zone in the ocean. And for the interannual variability, then this propagation of the vertical Rossby wave propagation is important. And we have used the bottom is the vertical Rossby wave propagation model can reproduce the phase and the upper the magnitude of the annual cycle while, except in the Eastern Pacific, where you have strong kinetic energy produced by the instability waves, which the shallow water equation model cannot reproduce, by the way. But that's another thing. That's only in the surface layer, so it's not really in the deep ocean. So much for the subsurface dynamics and observations. And I want to mention that during the 2016, 2015 El Nino, after the 2016, 2015 El Nino, in the Makassar Strait, you see this is depth, horizontal is depth, vertical axis is the time. You see the Arnold Gordon has measured a significant subsurface intrusion in the Makassar Strait. The surface is also to the north, but the subsurface to the south. And this southward intrusion is in good agreement with the interannual variability of the NESC, North Equatorial Subsurface Current, which suggests that the NESC perhaps has penetrated through the western boundary current, the bottom of the western boundary current, the bottom of the Mindanao eddy and Halmahera eddies into the Indonesian seas. Minty Lee and is working with Arno and me to study the analysis of this. The water, the TS curve suggests that this water does not come from the Mindanao current in the subsurface. Another very important thing I want to mention, which is the multi-scale variability, is the western boundary reflection at the gappy western boundary. Right now, there's a common prejudice that this western boundary, the Rossby reflection at the western boundary is linear. Actually, they are not, because you have strong western boundary current that flows by these gaps of the western boundary. This is example. The second column is example of anticyclonic eddy, downwelling Rossby wave propagating through a gap of the barrier in the middle of the ocean. The eddy actually is not very large. It's only 60 kilometers in radius, and the gap is about 220 kilometers. So it looks like large, but actually it's not. But the Rossby wave will propagate through the gap without much interruption. But the magnitude, of course, decreases quickly because of the friction or diffusivity associated with the barrier, because of the energy lost due to the barrier. But if you have a western boundary current that flows by this this gap from south to north, and at critical intrusion state, the eddy can perturb the western boundary from penetration, cyclonic penetration, anticyclonic penetration into a leaping state. Then after the eddy goes by, you have anticyclonic eddy that propagate into the western basin. So, and we have studied a lot of cases. So basically the story is that if you have a steady anticyclonic western boundary current, the eddy will propagate into the western basin. And if you have a steady leaping western boundary current, the eddy will not stop, will not propagate, will be blocked by the western boundary current. But if you have a critical western boundary current that shifts the state due to the perturbation of the eddies, you have opposite side of the Rossby wave that propagate to the western basin. And the right-hand side is the altimeter that shows you an example of this. You see the Kuroshio that flows inside into the South China Sea during 2017, April the 16th. And anticyclonic eddy approaching this western boundary current that actually in the next panel, it will show that western boundary current will become leaping. And you can see the anomaly field that subtract the western boundary current. You see anomaly is the upwelling Rossby wave that propagate to the west because of the shifting of the western boundary current. And this, there are many other cases we have shown that they all, so this theory is in agreement with the altimeter data. So this also applies to the entrance of the Indonesian seas. This is the mooring measurement at the Maluku Channel. This is the Maluku Channel. Okay, you can see that the zonal current is in winter is to the east and the relaxing summer east. Relaxing summer is annual cycle. That's because of the Mindanao loop current that extend to the northern Maluku Sea in winter and relaxes in summer. But during, this is also, the meridional velocity also is strongly influenced by the Mindanao loop current. But in the summer, in the 2014 El Nino, we see a significant westward and southward current anomaly produced without any reason, not because of wind. The drifter trajectory shows, and modeling shows that you have the mid-North current that shift from climatological intrusion to a very leaping state. This shifting causes the sea level in the northern Maluku Sea to rise and pushes the current to the south and to the west. That's the reason of the current anomaly. And we do see, we have moorings between the Talao Island and Morotai Island. There are 3 moorings. We do see that in winter, the current is strongly to the east, suggests the mid-North current retroflexion. And in summer, this loop current, this mid-North current disappears. Basically, it shrinks to the north. So this suggests that at the entrance of Indonesian seas, the mid-North current is strongly nonlinear and shift path. So this is important for the study of the interbasin exchange. Traditionally, people thought that the Rossby waves coming through the Halmahera Sea and propagate as Kelvin waves into the Indian Ocean. And there's also Kelvin waves coming to the Makassar Strait from the Indian Ocean. But actually, observations shows that during the 2015-2016 El Nino, the Maluku Sea signal, the current is nearly zero in that period. So there's no significant Ross wave coming from the Maluku Sea. Through the Halmahera Sea, the transport interannual anomalies is much weaker than in the seasonal cycle, which is not true because in the Western Pacific, interannual should be much larger than the seasonal cycle. This also suggests that the transport is only one spectrum. So this also suggests that the Rossby wave signal didn't come through the Halmahera Sea into the Indonesian seas. Now, these two suggest that there's no way for the Rossby wave, Kelvin wave, equatorial Rossby wave signal to become Kelvin waves in the eastern Indonesian seas. Most likely signal is through the Makassar Strait. But then the question is, how can the Makassar Strait Kelvin wave reach the Western Australia coast? Because you don't have a waveguide. So we need to study this. Next, I will talk about the Indo-Pacific interaction through the oceanic channel, which is what we justify all observations. And during the 2016 negative Indian Ocean dipole, we see the westerly wind forces the warm SST in the eastern Indian Ocean and downwarding Kelvin wave propagating to the Indonesian seas. And this, at the same time, the Pacific Ocean was just finishing the 2015-2016 strong El Nino, and the western boundary reflection was producing upwelling Kelvin waves that is trying to develop this La Nina state. And because of this Kelvin wave from the Indian Ocean, downwarding Kelvin waves, the La Nina development was halted. And the strong Indonesian through-flow anomalies on the Indian Ocean side between the Java and Australia, it indeed shows very strong Indonesian through-flow reduction, transport reduction, because of the Kelvin wave. So this suggests that the Indian Ocean Kelvin waves forestall the development of the 2014 La Nina. And direct measurement of the Makassar Strait transport and in the Halmahera Sea transport indeed shows that you have strong northward anomalies of the current that produced by the downwarding Kelvin propagating from the Indian Ocean through the Maluku Channel and through the Lombok Channel, Lombok Strait and Ombak Strait into the Makassar Strait and then propagate to the Maluku Channel. And this Kelvin wave forced ITF anomaly transport is nearly twice as large as those produced by ENSO. So this is significant. And this was simulated by ORE that shows clearly the Kelvin wave come in and you see the Makassar Strait current is anomalies to the north and into the Sulawesi Sea. So this Kelvin wave propagation has been basically overlooked in the past in the interbasin study and should play a very important role in the climate change because we know that during hiatus, the Pacific cooling is responsible for the global warming slowing down. And then we also noticed that during the recent 7 years, the Pacific warming is accelerated. One of the reasons of the acceleration is because of no La Nina development after the 2015-2016 strong El Nino. And if there should be a La Nina development like those in the, after the 1997-98, then we should have a cooling in the Pacific Ocean. So the warming in the Pacific Ocean is most likely induced by the ITF anomaly. And we have a couple model experiments to show that actually these ITF anomalies can induce the Quito phase shift. And for the nearest 2019 extreme Indian Ocean dipole event, the Pacific Ocean prediction now usually do not consider Indian Ocean. They predict the 2020 is a neutral ENSO. That's what's before April of this year. But then since June, they start to change the prediction as it's half of the probability is a La Nina event. That's because in the subsurface, you have these cold temperature anomalies produced by the 2019 IOD, one of the strongest IOD on record in history here. And this IOD should produce upwelling cavities into the Makassar Strait and should produce heat deficit in a subsump clan of the Pacific Ocean, which then surface up in about June of 2020 that is controlling the surface air-sea interaction. So I think that the interbasin interaction through the Indonesian through flow is indeed inactive at work that controls the Pacific climate that in the past, most of the study has overlooked. Last but not least, I want to mention that this Indonesian seas measurement is so important that, remember in the past, we just based on the Makassar Strait measurement, we noticed that the waters in the Makassar Strait from the North Pacific. So we draw the Great Ocean Conveyor Belt as the South Pacific water moves to the North Pacific and overturns into the surface and feed into the Indonesian seas to form the Great Ocean Conveyor Belt. In this picture, the South Pacific is just a pathway. There's no active role in of the South Pacific Ocean circulation in the Great Ocean Conveyor Belt. But if we do the measurement, we see that actually the western boundary current retroflect strongly into the North Pacific gyre and joins the North Pacific Ocean in the surface. And also in the Halmahera Sea, we have measured about 2.4 sphere drop transport of the South Pacific water into the Indonesian Sea. And that's only one channel, which is Jayaloro Strait. And there's another channel next to it called the Gobi Strait, which is nearly as wide and nearly as deep as the Jayaloro Strait. So this transport can easily be doubled. And if this transport plus the retroflexion of western boundary current, we produce a strong South Pacific water that joins the Great Ocean Conveyor Belt through the Halmahera Sea, through the retroflexion into the Makassar Strait. Therefore, the new picture should be in the center that both the South Pacific water and North Pacific water, the overturning circulation that contribute to the Great Ocean Conveyor Belt. Actually, the South Pacific contribute more because it includes the equatorial upwelling. And that's why in the past, people use island rule to estimate the ITF transport because there's no overturning circulation that contribute to the Great Ocean Conveyor Belt. But if you should have the overturning circulation in the South Pacific Ocean, you should not use the island rule because that does not, the traditional island rule do not consider the upwelling contribution. Okay, now given the importance of the Indonesian seas observations, we have been conducting measurement with the Indonesian Institute of Science Research Center for Oceanography for many years, since 2014. And you can see the mooring arrays expanded and the CDD stations was also expanding. And last year, because of the, the 2019 should be implemented by the end of the year, or it was postponed until earlier of this year, but then because of the COVID-19 event, it was on hold. So we hope that this cruise will be conducted soon in 2020. So this is a new plan. Basically, both of the China and both the outcasts and the RCODP are happy with the collaboration. And the current situation that the IOCAS is mostly responsible for the northeastern channel and some of the southern channel and in the Makassar Strait. The FIO of SOA will be deploying moorings in the northern Makassar Strait and in the Lombok and SAPE Strait, SAPE and Samba Strait. And the US Minty program will resume the instant mooring site. And if all these moorings should be in place, then we would have the, perhaps for the first time in history, we would have all the channels of the Indonesian seas covered so that we would have the mass and heat balance calculated. And this moorings also was in cooperation with the moorings in the mooring arrays of the IOCAS in the Western Pacific along the 130 East and along 140 degree East, so that it will form a very nice observational arrays to measure the main streams of the Pacific Ocean, both in the surface and subsurface and in the Indonesian seas. So basically, I think today I want to cast in the ideas that we have strong 3D circulation in the Western Pacific Ocean, and they are well supported by observations. The dynamics of the subsurface circulation appears to be the low order volcanic mode responses to the wind current forcing. And we suggest no shadow zone should exist near the eastern boundary. We have identified new ITF branches in the Indonesians, which is through the Halmahera Sea that was calculated for the first time, and in the Maluku channel, which is also the transport, upper layer transport is estimated for the first time using the subsurface mooring. And we suggest the Indian Ocean wind force common wave propagates through the Indonesian seas and influence ENSO. This has been supported by a lot of evidence by reanalysis data. We suggest that this could also contribute to the latest global warming acceleration. And finally, we suggest that the South Pacific Ocean overturning circulation should play an important role in the Great Ocean Conveyor Belt. And we have already figured out a way how to estimate this South Pacific contribution based on the Indonesian seas measurement and based on the cross-equatorial transport. Thank you.
Thank you, Dong Liang.
Yeah.
So, question and comment. Please
I guess I need to.
Yep.
Yes.
Oh, yeah. Please raise your hand first, please. Sun-Hyun Nam, please.
Yep. Thank you, Dong Liang, for nice presentations. I'm not familiar with the circulation in this particular area, and I've learned a lot from your ongoing and planned works. So thank you very much. And my question, or actually comment, is aligned with Wenxi's comments on the Xiaopei's presentation. So as Ken emphasized, we need co-design the value with the stakeholder, and we need to think about the social impacts and contribution to the society of this kind of science, right? So what's the specific social contribution of the better understanding of Western tropical Pacific and better prediction of the low latitude boundary current and circulation in and around the maritime continent? So what's the social impact, do you think?
Okay, thank you. Very nice question. I think that helped me to rephrase the purpose of my talk. Number one, the biggest social impact of this measurement is the prediction of ENSO and decadal variability, because we know that ENSO starts from the western boundary current, basically from the vicinity of the entrance of the Indonesian through flow. And in the past, we do not have any information from there. So we have to wait until the ENSO develops before, so that we can predict the ENSO. That usually is pretty late, after June, right? Like what we have in 2020. So if we should know what happens inside the Indonesian seas and at the entrance of the Indonesian seas, if we should know what happens with the western boundary current, we probably can make the prediction earlier of the, for example, the 2020 La Nina. So that's the number one societal effect. Number two is that, as you're right, because in the past, this monitoring array is basically a research focused. It's not really focused on the operational. So the next step, if given that if like CSK or some other program should give us the support or give us the justification, then we can maybe increase the biological and chemical measurement, and maybe persuade the Indonesian government to allow us to do the real-time transformation and stuff like that, to make this arrays really operational and can be utilized by the society. And number three is that just aside from the climate forecast, aside from the real-time measurement, the Indonesian seas is one pole of the one pole of the ENSO and one pole of the IOD. So it's really the area of the strongest interannual variability, much stronger than the seasonal cycle. So IOD directly influence the upwelling of the Java coast and also in the southern Indonesian seas. The ENSO directly influence the circulation at the entrance of the Indonesian seas. And this signal can propagate, inside the Indonesian seas back and forth. And that would greatly, influence the fisheries and the productivities, many things, economies and environment inside this maritime continent. I think that's very important for the livelihood of the surrounding countries. If we have the information in the ocean, what's going on. And these countries, nearby these countries are very, very ocean dependent. So, their economy, everything, their livelihood are so much dependent on the ocean. And they should, and right now, as far as I know, I talked to all these people, even the scientists in the Indonesian seas, they didn't realize that ENSO and IOD should have such a strong impact to them. And they didn't realize that with the proper prediction, we can really tell people beforehand that what we should do. Or we can, reduce or alleviate the destroys by this anomalous event. I hope I have answered your question.
Yeah, thank you very much. Yeah.
Okay.
Thank you very much. Yeah, Andres, please. Andreas, your microphone is still off.
Okay.
Yeah.
Thank you, Ando, for let me know for the mic. Very nice presentation. You mentioned about something very different from what I haven't seen before. I mean, I've been working for the instant project for 5 years in early 2000, but now I'm focusing more on the coastal ecosystem. But the interesting thing for your observation is it's in this area, I think Banda Sea, Halmahera, Livamatola, and Maluku, and so on, is very important area for capture fisheries for Indonesia. So with this kind of data observation, maybe it will be good if you also, maybe some of your scientists, I don't know, LIPI or whatever institution could able also to combine with another data. I mean, most of the research crews mostly focusing on the physical aspect of the ocean, but the information related to the material transport or primary production and so on is limited. So this is what some time ago I've talked to some scientists, McMaden and also Arnold, for this thing. Then please try to combine with another parameter, not only chemical, not only physical, but also chemical, biological, and as well as it's possible the social community aspect is possible. But doing the field observation only for physical parameter is sometimes, I mean, I feel it's not, many things need to be left behind, something like that. this is just my suggestion for the next. Thank you.
Yeah, thank you for your suggestion. Actually, you're right. Actually, we have been collaborating with RCO-LEPI scientists and collect water samples and collect the zooplankton, phytoplankton, microplastic samples. And yeah, for the ecosystem environmental, we do not have fishery samples, of course, because we have limited capabilities on board of the ship. We mostly rely on the LEPI scientists to analyze those samples. I don't know their working stage right now because maybe they're too busy to analyze the samples yet. But you're right, we should push forward for like collaborated research, both physical, biological, chemical. And you know, as a foreign scientist, we do not have a lot of access to the fishery data inside the Indonesian seas. A lot of samples we cannot carry overseas for analysis. So, maybe in the CSK program or in the decade year, the UN Ocean Decade, we can perhaps allocate some resources to motivate the local scientists to do more analysis and to do more publications, to do more scientific researches, instead of just collect the data and put them into the refrigerator of the lab. That I observed is often the case, which is for me is helpless. But we'll move forward with this. This is one of the directions we want to move forward with the Indonesian scientists. Yes.
Thank you, Don Liang.
Thank you, Andreas. Don Liang. Any other comment or question? I have one question and one comment to Don Liang. Oh, Wensi first, please.
You first, please.
Oh, okay. So the spring barrier issue is a huge scientific question, and it is. I'm happy to see that your study may contribute to the solve the long-term big questions on ENSO prediction. So so regarding to this spring barrier issues, what kind of data? So most of the data you are using for the spring barrier within the Indonesian seas, and they're very difficult, to use for the operational, forecasting purposes. But what kind of data do you think we can, use for the ENSO prediction, to show that this is the reason of spring barrier or something? So that is one question. And another comment is you show the nonlinear interaction between the eddy and western boundary current. This is very good. And do you have any? Question. So, do you have any plan to work with the fishery people because the the behaviors of eddies after passing the strait will impact to the fishery activity. So maybe you can come close to the UN decade goals. So if you have some ideas to work with the fishery people in the regard of the eddies. So two different questions, sorry.
Okay, thank you. I know you have asked a very sharp question. For the spring barrier, the prediction spring barrier issue, spring barrier, or you call it prediction barrier or correlation barrier, that's mostly a surface SST issue. It's a surface SST that the correlation do not go across the spring barrier, very high correlation do not go across the spring barrier. But it doesn't say the subsurface temperature. If you have the subsurface temperature, you will be able to cross the spring barrier. As I show you in the 2020 subsurface temperature and in the 2015, 2016 subsurface temperature. Of course, these are only for the strong events. But in the Pacific Ocean, when you have no signals from the Indian Ocean, you also have the western boundary reflection issue. So I think in terms of to overcome the spring barrier issue, the Makassar Strait subsurface measurement, the Makassar Strait measurement is important. That directly tells you the Indo-Pacific interaction, and if that should be assimilated into the model, into the forecast model, that should play a role in overcoming the spread barrier. And the western boundary reflection, the interaction of the Halmahera eddy, Maluku eddy with the reflection of the Rossby waves is another issue. But unfortunately, this part of the study is very primitive, and we are still not very clear the exact reflection process of the Rossby waves. I have only used the simple model to show that unidirectional western boundary current, how it interacts with the Rossby waves. But if you should have multiple western boundary current, like two colliding western boundary current at the entrance of a gappy western boundary current, that interaction with the Rossby waves is complicated, you know. So that's I would say can be a direction of future research, and a very important direction of future research. And the second question about the fishery, unfortunately, I'm not an expert about fishery, but I only know about eddies. If the fishery people think that my eddy reflection and prediction can be useful to them, I'll be happy to share my information to them, I guess. And as far as I know, the Chinese fishery is not as advanced as in Japan, like, or in Norway, in the international community. They are still basically doing the fishing like based on their experience, based on their empirical rule of thumbs. And for the accurate prediction of the salmons and economic fisheries, you know, Japan and other countries are very, very good at that. But I'll be glad to share my study of the physical circulation information to them, and if that can enhance their harvest, I'll be happy. I'll be glad to hear about that. How's that?
Yeah, thank you. Yeah, I understand the position. Thank you very much. PC, please.
Hello.
Yes, I can hear you.
Okay. Thank you very much, Dongliang. This is very wonderful. You know, our work has been done over last 6 years. You know, in the spirit cooperation, particularly with our Indonesia colleagues. I think, you know, one issue is kind of also for you this question, whether ITF or broader Western Pacific could be part of CSK-2. Yeah, this is my first question. Because I have been thinking about how to kick off CSK-2, a Science Action Plan. You know, I think with more and more presentation in the semester, the issue and also the scale become more broader and more complex than we expected at the beginning. And the second, to Dongliang, you know, because as I said, the UN decade, you know, emphasize the solution-oriented, you know. The ocean data, of course, can serve multiple purpose for climate, even for ecosystem health, even for biodiversity conservation, right? Right, broadly, in broader sense. So because there are so many proposals, you know, mentioned, they can address a lot of issues. But when you go to really specific issue, you will find the observation, the work had been done is far from enough to address those specific issues. So that's why I think many questions today actually start to address the behavior change issues. What kind of a concern? You know, in this case, I have to ask, because most of the work has been done in the Indonesia waters. So what's the societal concern that Indonesia counterparts wish to address? Fishery or climate impact? So this is something I think maybe at the next stage, the Indonesia stakeholder really need to give a clear, you know, some kind of guidance. Right. Some, I think, you know, I think this work certainly can address clearly, but some maybe you can work more with other stakeholder groups, local fishery community, as you mentioned.
Mm.
And then in that process, I think we can ensure the final product or resulting knowledge could be more visible and useful someday. So, but of course, this is the suggestion based on you wish to propose this kind of activity to the UN decade. Because UN decade proposal, they require some kind of a criteria, to be endorsed. Even, data, information, resulting knowledge sharing and accessible, those things. So this is something I think I would suggest to all of us to start thinking about that. Right.
What kind of like a UN standard they require? Like, can you give an example?
Yeah, sure. There are several criteria. I can send the draft implementation plan to you.
But can you just mention a few?
Yes, 1, 2, 3, 4, 5, 6, 7, 8. 8 criteria.
8 criteria. Okay.
Yes, it's hard because you see, first, the proposed action must contribute to the Ocean Decade challenges. So there are 10 Ocean Decade challenges. It's very much, solution-oriented approach. Not science from science to science. It should be from science to solution to end user. So this is the fundamental approach. Second, I think is the generation of knowledge that can contribute to decision making, to biodiversity conservation. And 3 is a co-design, co-development approach. That means, you have to, co-design, co-develop with the stakeholder. For instance, if you feel fishery production is very important, you see some fishery, scientists need to be engaged, right? I think your group, a lot of climate scientists already engaged. The fourth one is data and the resulting knowledge sharing. Data and the resulting knowledge sharing. You see, we see a lot of observation has been ongoing or to be conducted. Whether those data or knowledge could be shared, right? The fifth one is, I think the partnership is, of course. I think for other one is not very important. Something like, work with the local and the endangered knowledge. I think this is not that important with relevance to this project. So this is something. If this project, you say, okay, we focus on service, observation service, okay? So you need to demonstrate whether the data could be accessible, what kind of knowledge could be generated, how this knowledge could be used, or what kind of prediction you have been provided, right? This kind of tangible outputs. If you focus on solution-oriented, as I said, okay, like a fishery, like the prediction of ENSO, so what kind of outputs? So this is something, the UN decade has been encouraging the research community to move forward. I know it's not easy. It's not that easy because this is as we understand, this is really a traumatic change to the behavior that we have in the past for long years. So just to remind us, because we are working for science for long years, we need to move forward. How our science could be really serving the needs of society. Not in a very general sense. I'm not sure whether I explain clearly or not, Dongyang. Not easy, even it's not easy to explain.
Yeah, Wensi, I think, I think not necessarily that the all scientists have to work for that. You know, some scientists need to work for that. So other scientists can keep working on their own science.
That's right. That's right. I said if we want to, you know, to propose as a UN decade actions, either program or projects, you know, that's why, you know, they will call the UN decade, not international decade.
Yeah. So that's that is, I think, up to the scientists, and scientists can decide.
Correct. Correct.
And may I go to the other issues? So for the Makassar and Halmahera and these AD and wave dynamics issues, I think these issues can be much, you know, more appropriate to TPOS, not to the CSK-2. The TPOS is looking for the, you know, new process studies contribute to the ENSO prediction skill. So I think the a part of your Donian's talk is maybe more contributed to the TPOS, I think. Yeah. So Donian, are you talking? No? Oh.
Dongliang, I cannot hear Dongliang.
Oh, okay. He also. So Dongliang, if you have some comment, please write on the chat. So again, we cannot hear the Dongliang's talk again. So Dongliang, could you please send a message on the chat? We cannot hear your voice. No, we cannot hear you. Don't try to talk, but we cannot hear. Okay, thank you very much, Donian. We need your message. All right. So, do you have any question or comment to Donian? If not, we already spent.
Ando-san.
Yes.
Who is talking? Hanung.
Okay. Yeah, please.
Okay. Thank you, Ando-san. I am very interested with Don Liang presentation, which one is related about new finding in Halmahera new ITF branching. Could Don Liang explain more detail, maybe in surrounding area, which is very important for us to make a baseline study, which you know that a stakeholder in Indonesia need this data to baseline study, which you know that in Banda Sea and Arafura Sea is the potential for fisheries. So if we have new finding related about the physical oceanography support data, is important for us to baseline study to support stakeholder make a better decision to conserve biological fisheries. Thank you.
So at this moment, Donian cannot talk. So okay. I would maybe I would introduce some his results. One is the his results show that there is a possibility to show the spring barrier issue. So spring barrier means that the ENSO cannot predict before the spring, and then his results show that if he or Indonesia can make a measurement in the Indonesian seas, there will be a possibility to break spring barrier issues. So I mean that the ENSO can be predicted even before the spring. Right now, at this moment, we can only predict the ENSO after spring, April. So May and June, we can see what happened. This year will be ENSO year or something like that. But we cannot predict before April or March. But if you can take a measurement in the Indonesian seas, we may be able to predict ENSO even before the spring. That is one result. And another one is the by using his AD behaviors, maybe there may have some, this AD behavior may impact to the fisheries in the marginal seas. So he may be able to provide physical oceanographic information to fishery people. Yeah, that is, I think, two important messages from the Donyang.
Okay, thank you, Ken.
So Donyang, if you can hear me, if I'm wrong, so please send message to Agus to correct. Thank you very much. So I think all presentation has finished for today's session. So I want to, finish this webinar's session. So Xiaopei or Cesar, do you have any comments on that, on today's session?
No, no comment.
Okay.
Thank you.
How about Cesar?
No comment, too. No comment. Very
Okay.
nice presentation. Thank you.
Yeah, thank you very much for Donyang and Xiaopei.
Yeah.
So,
Anderson, I have a question.
Okay.
I have a suggestion. So can we make the presentations available like PPT or PDF? Because sometimes it's difficult to follow the whole presentations. I would, is it possible for the question to presenters, can we do this? Make the presentation available to look one more time.
Okay, so for the presentation, and also I'm recording this conference, these files I would like to ask Wenxi to upload to the IOC-WESTPAC webpage.
Or,
yeah.
Yes, Ken. As discussed, no problem.
Okay, okay. And then under the PowerPoint file or PDF file, we will put the email address for the presenters. Email address of presenters for the participants can ask by email. Is that okay?
I should be okay, no problem.
Okay,
Right?
okay.
Right.
So we do this way. So maybe soon after this webinar session, I or Wenxi or Mui will announce which address you can access to for the PowerPoint file or PDF file and webinar recording files. So then you can ask to the presenters anytime. So I do want to do this way. Yeah.
Yeah. Can I have one comment?
Okay.
I remember, I think in the original guideline we distributed that we still expect each invited speaker to come up with some kind of concrete idea how to kick off CSK2. I think probably for the future presentation, I think our speaker should consider something how to kick off CSK-2.
Okay.
Right. Okay. But today is wonderful. I think we share a lot of our scientific knowledge and also their observations.
Okay, so after the webinars, August 7th, we want to ask to all presenters.
听见了。
听见了。
we
sorry.
come here.
Sorry. Okay. Now it's resumed. Right now, just now, the bandwidth is really low.
Dong Liang always disappear at the critical moments.
That's the problem. I said the IOCast should enhance the construction of the internet.
Right. Okay.
But I want to respond briefly to when because I now give the opportunity. The reason I think WESTPAC can play a role in the Indonesian collaboration is that when we contact the Indonesian government, we want to persuade them that these observations, this data are useful for service, are useful for their solutions, are useful for their policy decisions. But usually it's much better if we present this in a international, multinational collaborative program. If we just present us as a Chinese scientist, sometimes they have, they are not very, they are reluctant to share the opportunity of making the measurement, the opportunity of the share the data of fisheries ecosystem, and they do not allow international scientists to study the biodiversity in the Indonesian seas. That's for sure. So I think that there's a lot of work that can be done from the UN, IOC, and from the WESTPAC point of view to help us strengthen this collaboration. And I think that's the part that TPOS probably will not be able to help us to solve the problem. I think, maybe I didn't understand this correctly.
Okay, yeah. But for your scientific ideas, is maybe more fit to the TPOS.
Yeah, but we talk about the service. We talk about the solutions now.
Okay. Yeah, WESTPAC is more appropriate. Yeah, we are intergovernmental framework.
Yeah, I think that Dr. Zano Arifin is very advocate for WESTPAC to cut into the collaboration inside the Indonesian seas. And that's actually my talk is motivated by him to give a discussion on this. So I mean, please think about it if this is important for the CSK-2 whatever.
Okay. So Nonaka-san, do you want to talk? Your microphone is on. No. Okay. Thank you very much. So already in Japan, 5:40. So I want to finish this session. Thank you very much.
Okay, thank you, Andrew.
Yeah, thank you very much.
Thank you.
Glad to see you.
Ken, Xiaopei, and Cesar for organizing this webinar seminars. So I think today, although most of us come from the scientific community, but indeed we should play a key role, particularly at the national level, how to engage particularly our policymaker to provide more funding, to our joint scientific program like the CSK-2. So I think from now today mark a very good turning time for all of you, interested in CSK-2 joint collaborations. Let's start considering how to kick off, the CSK-2 in a substantive manner. Yeah, thank you very much, Ken and Cesar, and also Xiaopei, and all our participants for today's webinar.
Yeah,
have a nice weekend.
Yeah.
Thank you.
This is also my words.
Yeah.
Thank you very much.
Bye-bye.
See you August 7th. Next webinar is.
Hey, how about we turn on the webinar? We turn on the camera and take a photo.
Yeah. So
let's turn on the camera.
Yeah. Okay, so please turn on your camera, and I will take a screenshot.
Right.
Yeah.
Wait a moment. Yeah, good idea.
Every time we should have this photo, no?
Okay.
Yeah.
So.
Oh, very nice.
Hold on. Let me put on all the screen. Okay.
Yeah.
Yes.
Big smile, wave hands.
Smile.
Smile.
Big sign. So,
Oh.
3, 2, 1, 0. Okay. One more.
Thank you.
Dr. Kang is driving.
So 3, 2, 1, 0.
Careful.
Okay.
Oh, yeah.
Okay, thank you very much.
Thank you.
Thank you.
Thank
you.
Thank you very much.
Thank you all.
Have a nice
Thank you,
weekend.
Ken.
Have a nice weekend.
August
Okay,
7th.
Have a nice weekend.
August 7th.
Bye bye.
Yeah, bye.
Bye. Thank
Bye.
you.
Bye. Thank you all.